Hello everyone, welcome back to Cambridge Guru once again. In the last video, we did some questions on exponential functions, exponential equations, and also on logarithmic functions and log equations. Um, in this video, we will talk about trigonometric functions. So, firstly, we will talk about radians and degrees. Then we will talk about unit circle. I hope you have some basic knowledge of trigonometry, that what do you mean by sine theta and cos theta, right? Those basic definition, not the definition, but the formula, that how we in a right angle triangle, what is sine theta was the ratio of the sides for sine theta and cos theta and tan theta, right? This basic knowledge I am, I'm supposing that you must know this, right? So next we will talk about what is called the unit circle. Then we'll apply that unit circle in solving some trigonometric equations, right? And then we will, if the time permits, we will talk about graphs of trigonometric functions and also the sine and cosine rule. Okay, so let us start with trigonometric functions. Before that, the first topic is radians and degrees. As you know that there is a unit to measure an angle, which we normally use is degrees, right? So for example, the angle 60 degrees, 45 degrees, and so on, right? Angle made by a circle at the center is 360 degrees, and so on, right? So the unit to measure an angle till now, what is known to us is degrees. But there is another unit which is used to measure and which is more practical to measure the angle is radians, right? So, but before that, why we need such a unit if we already have a unit to measure angle? So, the concept of getting an idea of radians is this, that if I ask you that, let us say this is one angle, and let us say it's in degrees, it is measured as 45 degrees, right? Now if I ask you that what is the measure of this angle, what will you say? Angle this will be again 45 degrees, right? What about this angle? This is again 45 degrees. But if I ask you what is the measure of this angle, again the angle will remain as 45 degrees, right? But you must be noticing here that if I name this as AOB, this angle AOB, you extend this angle, this arc to infinite, the angle will remain as 45 degrees. But the moment I reach at these endpoints, you must have noticed that this 45 degree is basically the length of the arc AB. Okay, length of arc AB I am denoting like this. Okay, so this is the length of the arc AB, which is 45 degrees. But now, since we are talking about the length of certain thing, which should be measured in units of length, for example, in centimeters, meters, millimeters, and so on, right? So if we are measuring length, then it should be written in units, in length terms, unit of the length, which is centimeters and meters. But here we are writing this length of the arc in degrees. It is not making very sense, right? So there must be some way which will relate degrees to this length of the arc, right? And if this relates to this length of the arc, then this is also a length of the arc, and this is also a length of the arc if we keep on reducing the radius of this part of a circle, right? So suppose I am saying that this circle is of unit length, this arc is of unit length 1, right? So we have an AOB, which is a sector of a circle of unit radius, right? Radius is 1 unit. This is we are supposing, right? Though this is not a unit circle, that will be studied later on. So okay, so now if I consider a circle, okay, extending this concept, which we have understood the need of using another unit, which is radian, extending this concept to the circle, as we know that angle made at the center, if we take the whole round, it is in degrees, it is measured as 360 degrees, right? And if I say that what is the measure of this, again this is 360 degrees, and if I extend this to the periphery of the circle, of radius 1 unit, so this length, this periphery, this length should also be 360 degrees, right? But as we know that this length is basically 360 degrees, it is basically the circumference of the circle, right? It is basically the circumference of the circle, which is measured in degrees as 360 degrees. Okay, so circumference, according to the formula of circumference, if radius is 1 unit, it should be equal to 2 pi, right? That means length, which is 2 pi, in a way it is written in degrees as 360 degrees. So now we have this relation that this 2 pi length of the arc is basically equal to 360 in degrees. And this is the basic relation, that if we simplify this, that pi can be converted to 180 degrees radians and vice versa. And this is the relation that is always used to convert radians into degrees and degrees into radians. And this radian is sometimes written with the C at this superscript. Okay, but if it is not written and you are dealing with angles, so it is understood that you are dealing with radians. If the C is not written and answer is given in pi or something else. Okay, but if you are using some numbers, suppose you are using 10, so that 10 you have to specify it is not written in degrees form, it is normally understood as is understood as radians. Okay, so if I'm writing that sine 60, so sine 60 degrees is basically root 3 by 2. Okay, but if I am writing as sine just 60, so degree is not written, so I will consider this as radian, right, whose value surely is not equal to root 3 by 2, because radians is something different from uh, degrees in this way. Okay, so basically you need to convert some radian into degrees and degrees into radians. Okay, it is very basic because this will be used in giving you the domain for solving any trigonometric equation. Okay, question will come for of using this trigonometric equation somewhere else also, right? So these basics you should know, that from where this radians comes out. So basic idea is the length of the arc, which is written in degree form, in angle form. Okay, and please remember this relation, that pi radian is 180 degrees. Now extending this pi radians to 180 degrees, we can write all the basic angles which are 30 degrees. Okay, so if 180 degree is pi, so 30 degree will be written as pi by 6 radians, 45 degrees will be written as pi by 4 radians, 60 degrees will be written as pi by 3 radians, and 90 degree is written as pi by 2 radians. Okay, why I'm using this? Because these are the basic angles which are normally used in solving trigonometric equations without calculator. Okay, so these pi values should also be on your tips. That pi by 6 is not actually 60 degrees, it is 30 degrees. Okay, student gets confused that 6 is written, so they consider this as 60. No. Okay, all right, so this was radians in degrees. I'm not going into giving you some questions of converting this. You may convert this just like you have converted these degrees into radians. Okay, fine. Next thing I need to talk about is unit circle. Unit circle, as the name suggests, is a circle of unit radius, but I'm not taking a circle of unit radius. I will consider or extend this concept to any circle of radius r. Okay, so let us say I have this circle. Okay, suppose this is our circle, this is our natural origin, this is the x-axis, this is y-axis, and so on. Okay, right, now consider a point P. Consider a point P which is making an angle of theta degrees with the positive x-axis. Okay, let us say this is your theta, and the coordinates of P I am taking as x comma y. Okay, meaning is this length is y, right, and this length is x units, and this is radius r, right? Now, what you have learned about sine theta and cos theta, the basic idea is to define uh, sine theta and cos theta for any angle, not just the acute angle. Till now, if you know how to solve or how to apply the sine theta and cos theta, that was related to just a single right angle triangle. But these sine theta and cos theta can be extended to any angle. That angle can be obtuse also. And now, what will be the sine value for, let us say, 120 degrees? This is how we used to calculate its value. Okay, extending that concept to any obtuse angle, right? So this is our basic, that if theta is lying in the first quadrant, meaning is in this case theta is acute, right? This time we will define sine theta, basically is defined as y coordinate, and you need to remember this concept, because then only you will remember the basic shorthand of knowing that in which quadrant sine, cos and tan will remain positive or negative. Right, so basic definition of sine theta is that it is the ratio of y coordinate to the radius of the circle, right? And cos theta is defined as x coordinate divided by radius. How we have defined this? Because if theta is acute, so in this triangle you can see that according to the basic definition of sine theta, it is the opposite upon radius or the hypotenuse. So opposite in this case is y, which is actually the y coordinate, right? So y coordinate upon radius, and cos theta is defined by adjacent upon hypotenuse. In this case adjacent is x, so we have written x coordinate upon radius. Okay, so cos theta, if theta is in the first quadrant, it is y by r, and sine theta is y by r, and cos theta is x by r. Okay, let me write it here. So this is x by r if theta is in first quadrant. Now what will happen if I transfer this theta to second quadrant? Okay, let us see. This theta is in second quadrant, so this point will be just a mirror reflection about the y-axis, right? And this angle will also be equal to theta, right? So now in this triangle, the coordinate of this point, let us say I am calling this point as p dash, its coordinate will be, the magnitude of the coordinates will remain same, x and y, but x, since it is in second quadrant, x remains negative. So I am taking this coordinate as minus x and y. Okay, minus x comma y. Now according to the definition of sine theta and cos theta, in the second quadrant, sine theta is y coordinate upon r. In the second quadrant, y coordinate is y just. Okay, so it is y by r. And cos theta in this case will be x coordinate. What is the x coordinate in the second quadrant? It is minus x. So cos is minus x by r. Okay. Now extending again this concept to the third quadrant, right? This point is the mirror reflection of this p dash, so its coordinate will be minus x comma minus y, because in the third quadrant both x and y remains negative. So in third quadrant I will write sine theta as y coordinate, which is minus y by r, and cos theta is minus x over r. Now side by side, let us take the value of tan theta also. So in quadrant 1, tan theta is a ratio of x and y, sine and cos. So in quadrant 1, tan theta is y by x. Okay, in the second quadrant, tan theta will be negative. Okay, so tan theta is minus y by x. But in the third quadrant, since both sine and cos are negative, so I will say that tan theta is plus y by x, just like in first quadrant. And in the fourth quadrant, x will remain positive like this, its coordinate will be x comma minus y, because y coordinates remains negative in fourth quadrant. So sine theta is minus y by r and cos theta is x over r, and tan theta will again be minus y by x. Okay, this is your fourth quadrant case. Okay, so simply if theta is lying in third quadrant, meaning it is 180, or you can say, let us say 210 degrees. Now before that, yes, that also I need to tell you that this angle, this horizontal x-axis is your 0 degrees. If I say I'm talking in terms of degrees, this is 0 degree, this is 90 degrees, this is 180 degrees, and this is 270 degrees, and this is again 360 degrees. This is your complete one circle. Okay, if I have to go again second round, so this will be 360 plus 90. Okay, so I will, in terms of radians, I will write this as 2 pi plus pi by 2, because 2 pi is my 360 degrees and I am going again in the anti-clockwise direction, so angle will be measured as positive. So 2 pi whole circle plus pi by 2, again 90 degrees, right, which is 5 pi by 2. Okay, if I have to again reach here, so this is how many times I have rotated 180 degrees? 3 times, so it is 3 pi. Then it is 3 pi plus pi by 2. Okay, and again this will be 2 full circle, so it will be 4 pi. Then 4 pi plus 5 pi by 2, then 4 pi plus pi, which is 5 pi, and so on. No need to remember the odd multiple or even multiple of pi by 2. That will not be asked in the exam. Just remember, why I'm telling you is because we always take the horizontal axis as the reference axis. Reference axis in the sense is that if you have to move to the second quadrant and you have to evaluate, let us say, sine of 150 degrees. So as you can see that 150 is lying in the second quadrant, because angle greater than 90 and less than 80 will lie definitely in second quadrant. So you have to reach here at second quadrant. So how you will reach at second quadrant? So please remember that reference value we will take, reference axis we will take as this horizontal axis, right? Now horizontal axis will be either, if you have to go to the second quadrant, you will take 180 minus pi, right? Suppose this is your horizontal axis and this is the second quadrant, so I have to get 180 and reach, subtract some angle, so 180 minus pi, right? If I have to go to the third quadrant, then I will go 180 plus theta, not pi, 180 minus theta and 180 plus theta in case of second and third quadrant. Similarly, if I have to go in the fourth quadrant or again in the first quadrant, that will be, for the fourth quadrant, this is 2 pi minus theta, and I have to go again to the first quadrant after rotating through one full circle, it will be 2 pi plus theta. Okay, so just remember that this horizontal axis you will take as the reference in order to move through the quadrants. We will never touch the vertical axis because that creates confusion. That's it. Okay, so all this will be used in solving trigonometric equation and how we will solve. Okay, so before that we will give some shortcut, not the shortcut, but just remember how we will remember where the sine and cos will remain positive. Okay, so as you can see in the first quadrant, both sine, cos, and the tan also, all the three remains positive. Okay, so in a unit circle, in the first quadrant, we say that all remains positive. All in the sense, all the 6 trigonometric ratios. But you will say we have considered only 3. So if sine is positive, then its reciprocal cosec is also positive, right? So 3 basic trigonometric ratios, sine, cos, and tan, and their reciprocals will remain positive. So that's why A. In the second quadrant, you must have seen that sine is plus y by r, but cos is negative and tan is negative. So we say that only sine and of course its reciprocal remains positive, so we write in the second quadrant as S in order to indicate the sign remains positive in second quadrant. Similarly, in the third quadrant, you must have seen here that tan is positive, otherwise sine and cos are negative. So we write here as T. And in the fourth quadrant, cos remains positive. So here we write cos. And of course, the reciprocals of all these will be positive. Right? So this is our basic norm, that ASTC, this shortcut you need to remember, right, in order to solve any trigonometric equation. And how we remember this ASTC? You can create a mnemonic for this, which is add sugar to coffee, 1, 2, 3, 4. Or you can also write or remember after school to coffee, after school to college. Sorry, not coffee, after school to college. That's how you can remember 1, 2, 3, 4, add sugar to coffee, and so on. All right, so this was about the unit circle, right? And as I said earlier, it is used in solving the trigonometric equations when the domain is altered. Okay, if I ask you what is sine, when this theta will be half, sine theta will be half, right? If I write this, solve this sine theta equal to half, right? So till now I'm assuming that you know this, that sine theta remains half at 30 degrees. So till now you will write the answer as 30 degrees. But since now you have studied that sine remains positive in second quadrant also, then it should also valid for, it should also give one obtuse angle also. So how we are going to deal with these trigonometric equation, right? So it depends on the domain of the theta. If you keep on increasing the theta, that theta is between 0 and 720 degrees. So 0 and 720 degrees meaning is that you are rotating two full rounds, 0 to 360 one full circle, and again 360 to 720 degrees is a second circle. So you keep on increasing or do whatever you want to with this domain. We just need to locate the quadrants where sine or any trigonometric ratios is given, that is positive or negative. Fine. So let us solve one question. Let us say example 1, that sine theta, solve sine theta is equal to half. The same we are using, domain is given as between 0 to 360 degrees. Okay, so 0 to 360 degrees meaning all the angles are positive, meaning we have to move anti-clockwise in only a single direction. So all the four quadrants basically I have to cover to give the angle. Okay, so first step is you find the principal value or principal angle. Principal angle meaning is without looking at the sign, whether it is positive or negative. Whatever crude knowledge you have about sine theta is half, it gives meaning for any right angle triangle, and theta is acute, right? So this gives you the basic principal angle. In this case, it is 30 degrees. So I will write this as that theta is 30 degrees. Okay. Now, second step in this case is look at the sign. Look at the sign of given trigonometric equation. Okay, looking at the sign of given trigonometric equation means that if it is positive or negative, right? Then think of the quadrants. Think of the quadrants where the given trigonometric function is positive or negative, as the case may be. So in this case, sine theta is given as positive. So we have to think now that sine theta remains positive in first and second quadrant. Okay, so this is my first quadrant and basic angle is 30 degrees, and I need to go to the second quadrant only because sign remains in ASTC. So S is your second quadrant. Okay, that's it. Now I have to reach at these straight lines. Okay, so from 0 degree I have traveled 30 degrees in the anti-clockwise direction. This has given me the one solution, which is theta is 30 degrees. Now I have to rotate this much angle and reach this straight line from 0 to this. Okay, so either I move to this straight line either in the anti-clockwise direction, or I can subtract 30 degrees from 180. That's it. So second angle will be basically this angle is 150 degrees, right? Because 30 is further to this. So fourth angle, next angle will be 180 minus 30 degrees, which is 150, right? So I will write here as fourth step, which is go for or solve the equation by moving to required quadrants by taking x-axis as the reference. Okay, this I have told you earlier that always we need to take the x-axis as the reference. So I have to move to the second quadrant. So what I did is pi minus 30 degrees. So 180 minus 30 degree is 150 degrees, right? You can check this. You can use your calculator and put it in the degree mode and just type sine 150. It will give you half, right? So things should be clear to you why it is half. I'm not giving you any, there are formulas to solve trigonometric equations that sine theta is equal to theta plus minus 1 raised to power n and so on. I'm not going into this. This is the very basic, and using this basic only, some books or some teachers, they have arrived at some solutions of trigonometric equations, but we are not going into this. We are just going with the very basic. Okay, let us take another example. This time, example 2, let us say cos theta is minus half. Okay, cos theta is minus half. Now cos theta remains, so first step is forget about the negative sign, just find out the principal value. Principal value is, you think that cos theta remains half at 60 degrees this time. Okay, it is a complementary of sign. So theta is your, theta means principal value. You can write this as principal value. Theta is 60 degrees. Okay, now basically cos here is negative. So now you think of the quadrants. Sine is negative, so think of the quadrant as cos remains negative in the second quadrant and in third quadrant. Fourth, it remains positive. Okay, so your principal value is 60 degrees. That means this angle from the horizontal axis is 60 degrees. So this angle should also be 60 degrees. So I have to reach here. This much I need to travel, and again this much I need to travel. Okay, so let us arrive at the first value, right? Let us arrive at this point. So it is what? Again, in the second quadrant I need to think. So in the second quadrant, how I move? 180 minus 60. So first angle will be, theta is 180 minus 60, which is 120 degrees. And in the third quadrant, I need to go 180 plus 60, right? So theta is 180 plus 60, which is 240 degrees. Okay, so these are the two solutions for this trigonometric equation given, because the domain was not given. By default, it was assumed to be 0 to 360 degrees, but otherwise it will play with domain also. Okay, so this was cos theta is minus half. Let us take another example, 3. Tan theta is let us say minus root 3 by 2, not root 3 by 2, minus root 3. And this time theta now is given as 180 degree and minus 180 degree. Let us take this. Yes. Okay. So between minus 180 and plus 180. Now forget for now about whatever the domain is given. You just focus on the step 1, that find out the principal value, that tan theta remains root 3. Forget about the sign, just concentrate on this root 3. So basic angle principal value of theta will be 60 degrees, right? So theta is 60 degrees, okay? Now think of the sign. Sign of the trigonometric equation is given as negative. That means tan remains negative in in second and fourth quadrant. Okay, so that means this angle is 60 degrees. I have to reach at this point, and this angle always from the horizontal axis. Okay, this angle is 60 degrees, right? Now, yes. Okay, now think of the domain. Domain is given as minus 180 to 180. Now first understand how this domain is given. One angle is positive from 0 to 180, because minus 180 it will go to 0 and again it will go to 180 degrees. So span is basically 360 degrees. Span of this domain of theta is 360 degrees, but this time half a circle you are going anti-clockwise. This domain is from 0 to 180 degree. I should write it down, that this you can rewrite as theta between 0 to 180 degree, and simultaneously, not simultaneously, that in this domain you need to go for from 0 and minus 180 degrees. So this is anti-clockwise and this angle is clockwise, because negative angles are covered when you go clockwise, right? But all the four quadrants are covered because span of theta is 360 degrees. I hope this is good. Okay, I mean, I hope you are able to understand this. Again, I'm repeating, go for the domain, look for the domain. If it is negative, then it is clockwise. If it is anti-clockwise, then it is positive. And look for the span. Spanning in the sense that you need to look for the quadrants. Through how many quadrants you need to go through, right? All right. So first deal with this anti-clockwise, means when theta is positive. So 0 to 180 degrees. So between 0 to 180 degrees, I have to look where tan remains negative. Okay, you can reconsider these basic questions, that when cos theta was minus half, we found out one value, theta is 60 degrees principal value. Now we need to look for the quadrants, that cos remains negative in which quadrants, second and third. Similarly, here I need to go from 0 to 180 degrees where tan remains negative. Meaning is tan remains negative in second quadrant, right? So 180 minus 60 will be your first solution. Okay, so theta is 120 degrees. Now you pick up your calculator, put it down 10, 120 degrees, it will give you minus root 3. Okay, simple. Now this domain is over, because 0 to 180 degrees only in the first quadrant, only in a single quadrant tan is negative. That's it. This is our solution for the anti-clockwise. Now for the clockwise, again I need to look for which quadrant tan is negative. So tan remains negative in fourth quadrant. So I have to reach at this point, but I need to go clockwise. So clockwise means it is just minus 60 degrees. So in this case, theta is just minus 60 degrees. Okay, so you can see that these answers of theta, they are in accordance with the domain given, right? Minus 60 is greater than minus 180 and 120 is less than 180. Otherwise, if this domain is given as 0 to 360 degrees, 0 to 360 degrees, so again 4 quadrants you have to move, but this time all the answer will be positive. One angle will be 120, and in the fourth quadrant what you will do is you will do 2 pi minus 60, means 300 degrees, if theta is 0 to 360. Fine. Now last question for this trigonometric equation is, let us consider fourth one example. Let us say tan square theta is 1. Okay, so in this case, please make this habit that if there is a degree 2 equation, there are chances of getting 2 solutions, and in this case you are getting 2 solutions. How you will find out these 2 solutions is you transfer this 1 to left hand side and write this as tan square theta minus 1 square equal to 0. Apply the formula of a square minus b square, which is a plus b and a minus b. Okay, tan theta plus 1 and tan theta minus 1 equal to 0. So tan theta you will get as plus minus 1. That is how you obtain directly as plus minus 1. But what is the reason? Reason is this, that you have to apply a square minus b square formula. Do not write tan theta directly as plus 1. Okay. So this is plus minus 1. So now you have the equation as tan theta equal to plus minus 1, and theta is given again as minus 180. Let us make it more complicated to 180 degrees. Okay, so break this domain into 2, 0 to 180 degrees. Okay, so again you break this now as, consider these this equation into 2 as 2 equations, 2 different equations, that when tan theta is plus 1 and tan theta is minus 1, right? So in this case you consider first equation tan theta is plus 1, and now look for the domain. So for tan theta equal to plus 1 and domain is 0 to 180 degree. So tan theta is plus 1, meaning tan is positive. So tan remains positive between 0 and 180 degree only in first quadrant. Okay, so in first quadrant your principal value has to be 45 degrees, and that is the answer for this one. And for minus 180 to 0, for 0, meaning in anti-clockwise tan remains positive in the third quadrant. So you have to go to the third quadrant. This angle is 45 degrees, but this time you need to move clockwise. So this angle is how much? See, this is minus 180. This is minus 180 because you are moving clockwise, and 45 degrees you have moved anti-clockwise, meaning plus 45. So I will write this angle as minus 180 plus 45. Okay, which is minus 135. Right? So between this domain, for tan theta equal to plus 1, these two are the solution, 45 degrees and minus 135 degrees. Now there is another equation which is tan theta is minus 1. Okay. If I'm moving that fast, please pause the video, right? Look for the basic question that I have done and then attempt this question. Now I have to consider tan theta is minus 1. So principal value will remain same. Forget about the sign. Theta is 45 degrees, but this time tan is negative. So tan remains negative in second and fourth quadrant. Now I have two domains for anti-clockwise and for clockwise, meaning 0 to 180 degrees. So between 0 and 180 degree, tan remains negative in second quadrant. Basic angle is 45 degree. So it is 180 minus 45, which is 135 degrees. And in the fourth quadrant, do I have to reach at the fourth quadrant? Yes, I have to reach the fourth quadrant because this time again I need to go clockwise. Okay, so this angle is minus 45 degrees. So for clockwise it is minus 45 degrees. So the complete solution for the given equation tan square theta equal to 1 is theta is minus 45 degrees, minus 135 degrees, 135 degrees and 45 degrees. Okay, so these four will be the solution. Okay, so this was all about trigonometric equations, solving trigonometric equations, unit circle, and radians and degrees. I hope you have enjoyed the video. In the next video, we will talk about graphs of trigonometric functions, because all this unit circle that will be visible in graph of trigonometric functions. Till then, take care. Bye bye. See you soon.